Think about this for a second. 95% of the entire universe is completely invisible. And until very recently, we didn't even have a clue where it was all hiding. Now, picture a telescope. Not one that just looks far away, but one designed to peek into the dark, invisible structure of reality itself. This is the Euclid Space Telescope. And yeah, what it's doing is absolutely mind-blowing. Let's just stop and think about this for a second. Everything you see when you look up at the night sky, the stars, the planets, the breathtaking galaxies, all that incredible cosmic beauty, that's only 5% of the universe. Just 5, so what about the other 95%? Well, it's invisible, it's untouchable, and it's quietly controlling everything from behind the scenes. This raises a pretty big question. How do you map something you can't even see? It sounds impossible, but that's exactly what Euclid was built to do. When we hear the word telescope, we usually think of taking beautiful, colorful pictures of space. The Hubble and James Webb telescopes have given us some of the most stunning images we've ever seen. But Euclid? Euclid doesn't really care about pretty pictures. It's not a camera in the traditional sense. It's a cosmic surveyor, a cartographer of the unseen. Its job is to measure how light from distant galaxies bends, stretches, and gets distorted as it travels through the cosmos. It's reading the invisible fingerprints left all over space. It sounds like something straight out of science fiction, but this is very, very real. Euclid is designed to observe galaxies up to 10 billion light years away. Let that number sink in. Because light takes time to travel, looking 10 billion light years away means we're also looking 10 billion years back in time. We're seeing the universe during its messy, chaotic childhood. It was an unfinished, turbulent place, completely different from the universe we know today. So what Euclid is doing isn't just astronomy. It's cosmic archaeology. I remember when I first heard this, I literally had to pause and just think, okay, my brain needs a minute to process that. We are digging through the history of existence itself. Now, let's meet the first of our invisible monsters, dark matter. Dark matter doesn't emit any light. It doesn't reflect any light. It doesn't have a glow. It's completely, utterly dark. But we know it's there because if you were to magically remove it from a galaxy, the whole thing would fly apart. The stars would just spin off into the void. Dark matter is the invisible scaffolding of the universe, the gravitational glue holding everything together. And Euclid's job? It's mapping out this hidden structure like a cosmic detective, tracing the outlines of a ghost. Here's a good way to visualize it. Think of the universe as a giant dark tent stretched out across a massive field at night. The galaxies are like little glowing patterns woven into the fabric of that tent. But what's holding the tent up? The poles. Dark matter is like those invisible poles. You can't see them directly, but you can see their effect on the shape of the fabric. Without those poles, the whole tent would just collapse into a useless pile on the ground. It's a bit creepy when you think about it. This massive, unseen structure is all around us, dictating the shape of everything. So, how does Euclid actually see the invisible? It uses a phenomenon predicted by Einstein called gravitational lensing. The idea is that mass bends the fabric of space-time. And as light travels through that bent space, its path also gets bent. Dark matter has a lot of mass, so it creates significant distortions in the space around it. Euclid is sensitive enough to detect these tiny, almost imperceptible distortions in the light from faraway galaxies. It's like trying to find a ghost in a room by watching how the furniture seems to shift and move on its own. We can't see the ghost, but we can see its influence. And the level of precision we're talking about here is just insane. This is the part that's truly wild. Euclid is so sensitive that the distortions it can detect are equivalent to spotting a single coin from thousands of kilometers away. When I first read that fact, I had to double-check it because it sounds completely impossible. The engineering required to achieve that level of accuracy on a satellite floating in space is just staggering. But dark matter is only part of the puzzle. Now we get to the bigger, weirder mystery, dark energy. Unlike dark matter, which pulls things together with gravity, dark energy seems to be doing the exact opposite. It's pushing the entire universe apart. And it's not just pushing it apart gently. It's causing the expansion of the universe to accelerate. Imagine throwing a ball into the air, and instead of slowing down and falling back, it starts moving faster and faster away from you. That's what our universe is doing. And the scariest part? We have absolutely no idea what dark energy is. Yeah, that part still messes with my head every time I think about it. This brings us to Euclid's true ultimate mission. Its goal is brutal in its ambition, to build the largest, most detailed 3D map of the universe ever created. This map will include the positions and shapes of billions of galaxies, stretching across billions of years of cosmic time. By analyzing this map, scientists can test our understanding of dark energy. They can test our understanding of gravity itself. Basically, Euclid is putting the fundamental laws of physics on trial. And this is where it gets really profound. What if our current theories of physics are wrong? What if dark energy isn't some mysterious substance, but a sign that our understanding of gravity is incomplete? What if gravity works differently over vast cosmic scales than it does here in our solar system? Euclid is designed specifically to catch that discrepancy. If its observations don't line up with what our theories predict, it could trigger a revolution in physics. Just let that sink in for a moment. We've built a machine to check if we've understood reality correctly. So, when you look at it this way, Euclid isn't just mapping galaxies. It's mapping the very rules of reality. It's testing the foundations of our knowledge. If the theory and the observation don't match, it means physics itself must change. The textbooks will have to be rewritten. For centuries, humanity has studied the universe by looking at light, the stars, the nebulae, the galaxies. But Euclid is teaching us a deeper way of seeing. It studies how that light struggles to travel through the darkness, how it's bent and twisted by invisible forces. It's not looking at the light, but what happens to the light on its journey. So the next time you hear someone say, "This new telescope can see 10 billion light years away," you'll know that's only half the story. What it really means is that most of reality has been completely invisible this whole time, and we're finally starting to turn on the lights. Thanks for joining me on this journey into the dark universe.